Our unit number 5 is dedicated to non-linear programming. So up till now, what we have seen, everything was linear programming. But now, from today onwards, what we are going to see for few days is non-linear programming. So the name of our unit itself is non-linear programming. So I guess what is the definition of the non-linear programming, and it is normally called as NLP. When it is written as NLPP, so that means non-linear programming problems, right? So NLP and problem. So non-linear programming problem. So now what is a non-linear programming problem? So if in the objective function or any of the constraint or any of the in any of the both in any of the objective or in the constraint section, if you have got a linear equation, so that particular problem is called as the non-linear programming problem. So no, basically in objective function or in constraints, or it may happen both objective function or constraints are non-linear equations, right? So in objective function or in constraints or both objective function or constraints, there are non-linear equation. So it is called as the non-linear programming problem, right? So now what is a non-linear equation? Non-linear equation will have the higher order of the variables, right? So for example, even if we take 15x minus x square, so even this equation is a non-linear equation. Why? Because there is a higher order of non higher order of a variable that is present here, right? So multiplication of two variables. So if there is another equation that is 2x1 x2 minus x3 square. So this is again there is multiplication of the two variables, and again the higher order for a particular variable. So that happens to be a non-linear equations, right? So these are either present the nonlinear equation are either present in the constraints or your objective function in itself is a nonlinear equation. For that particular problem we call it as the non-linear programming problem, right? Somewhere in the if you remember, while we were seeing the local variables and the local optima, global optima, or global, sorry, local maxima minima or global maxima minima. In that particular section, I've told you that there is there are two type of equations which are unimodal and multimodal. So when you have multiple maxima and minima in the equation, so you get a multiple peaks and the multiple peaks, and that particular function is a multimodal. But if you have a equation and if we are going to plot it, right? So if there is x here and fx here, you know what may happen, no? If you are getting something like this, so this is your unimodal function, right? So you're not getting a multiple what you can say multiple peaks and the multiple values in this particular equation, right? So this particular is just the representation of a unimodal function. No? Not only this, even this particular even this particular case is also a unimodal function, right? So maybe here you have no x1, right? So here somewhere you have x2, right? And let's say that this is your optimal point x star, right? So here it is f of x, here it is f of x1, and here it is f of x2. So at this particular structure, no, what you can say, x1 is less than x2 is less than x optimum, right? So this is that particular case. Even here, no, we can say it in the other manner. Let's say that this is this is your x star, and here it is x1, here it is, somewhere it is x2. So this is f of x1, this is f of x2, and no, here you can say that your no, x star is less than your x2 is less than your x1. So x1 particularly is on the higher side. So this is your case 2. So this what I'm going to trying to tell you is these are the unimodal functions, right? So unimodal function, that is very very right word to remember. So these are the unimodal functions, right? Now what we are going to do is we are going to deal with the non-linear programming, in which there are two variables. There can be a single variable, multiple variable, but we are going to start with a single variable, and within a particular range you have to find out the maximum or a minimum value, right? So this is separate here, not to be related with unimodal. I'm going to treat with what equations that we are going to solve now as a nonlinear programming will be all unimodal function, right? So, so I created a background to just make you imagine what is a unimodal function. Now, if I have to see what is what we are going to see in few of these lectures, uh, we may be given an objective function. Let's say we have an objective function. They'll be telling us to either to maximize or minimize, right? And they will be giving us they'll be telling us to maximize or minimize this function within a particular range of the variable, right? So when there will be a problem, you'll be understanding how the problem is solved, right? So this is this is how the numerical will be framed. They will be giving us maximize any function, and they'll be telling us to find out the maximum value or the minimum value in a particular range. So I'll be starting with the numerical directly, and via that you may get what I'm trying to mean, right? So the method that we are going to see today is the dichotomous search method, right? It is a sequential search method. So dichotomous, sorry, it is dichotomous search method. It is a sequential search method. So we are going to follow a certain sequence. Sequential search method. So I'll be directly starting with the numerical, and via numerical I'll be explaining you what does that actually mean, right? So the question is, find the maximum of f is equal to x 1.5 minus x in the interval 0 comma 1 within 10% of accuracy using dichotomous search technique, right? So now what we are going to do is we are going to find out the maximum value of this given function x in bracket 1.5 minus x in the interval 0 to 1, right? If we start in the interval, if there is 0 to 1 is a very long interval, right? You can't say it is a short interval, though it is like 0 comma 1. It seems to be a small interval, but there are many numbers within this particular range, and that is a very big range. And among this big range, we have to find that particular value, which will be giving us the maximum value for this particular function, right? So now, because if it would have been a software, it would have been like at the it would have been found to 100% accuracy. But now that we are doing in a manual way, they are expecting only 10% of the accuracy with us. Now what we can do, no, with this particular, I'll be telling you how to solve this particular numerical, and then I'll be telling you, a different trick, or particularly you can say how to use this 10%, or where this 10% accuracy phenomena can be used. As of now, we are not going to particularly deal with or consider 10% accuracy. I'll be telling you when particularly this has a significance in after solving or completely solving this particular numerical. Now let's try to solve this particular numerical. Now no according to this, we have an interval 0 and 1, right? And in 0 and 1 we have to settle down to a particular point which will be giving us the maximum value of the given function. So now there are multiple points in between 0 to 1, and somewhere we'll have to start. Somewhere at some of the point we'll have to start, and then only we can think of that particular point and is giving the maximum value or not. So there are multiple values, and I can't do multiple calculations, right? So I'll have to decide some algorithm or certain techniques, and this dichotomous search is one of the algorithm or one of the method that has been developed to find out the maximum value, or to satisfy the objective function, right? So what we are going to do, we are going to take mid of this particular value, that is in mid of this particular interval, which is 0 comma 1. So it will be 0.5. I'll be consider this as this completely as L0, right? So L0 stands for the initial interval, and this is L0 by 2, right? So this is L0 by 2. Now here what I'm going to do is I'm going to consider two values, right? I'm going to consider two values, one year and one year, to to start with, right? So let's say that this is x1 and this is x2, right? The difference between this x1 and x2 is represented by delta, right? And again this distance is delta by 2, and this distance is delta by 2, right? So mathematically I can represent x1 as x1 is equal to L0 by 2 minus delta by 2, right? L0 by 2 minus delta by 2, and x2 as L0 by 2 plus delta by 2, right? It is very simple to understand, right? X1 is equal to L0 by 2 minus delta by 2, and x2 is equal to L0 by 2 plus delta by 2. And within this very small range, that is delta, we are going to check whether this whether this particular, we are going to get the maximum value or not. If we are not going to get the maximum value, we are going to move ahead. We are going to eliminate certain region. Now let's find out what is the value of x1 here. So here x1 can be given as, x1 can be given as what is L0 by 2. It is, let's define L0 first. So here L0 is equal to how much? L0 is 1 minus 0, that is 1, right? So L0 particularly 0, 1. No? So 0, that is your L0 initial interval is equal to 1. So therefore x1, and what we are going to do is we are going to assume delta as very, very small and assume delta as 0.001. So now this is the standard delta that is being assumed. So even if the in example, if it is not given the delta value, so you can assume it as 0.001. And if in exam it is given delta as 0.001, so what value of delta that is given in the numerical, that you have to assume or that you have to consider. But if the value of delta is not given, the standard practice of considering delta is 0.001, right? So we are going to start with a very small range. If we keep the the range, if I keep the delta value as large, there is no use of considering delta and doing so iteration. We are going to move step by step, right? And for that particular step also, we are going to take small steps. We are not going to take big steps. Otherwise, the answer is going to come wrong, right? So let's find out what is x1. X1 is now here 0.1 no, minus 0.001 divided by 2. If you do the calculations, you'll be getting this value as 0.4995. So we are going to consider 4 digits after the decimal point, right? In x2, I can write it as 0.5 plus 0.001 divided by 2. It is equal to 0.5005, right? Now what I'm going to do is I'm going to find out, I'm dealing with the functional values, right? So the functional value I have to find out the maximum of f. I have to find out the maximum of the function. So what I'll have to do, I'll have to find out what is f of x1. F of x1 is equal to what? Instead of x, we'll have to consider x1 and substitute accordingly. So it is 0.4995 into 1.5 minus 0.4995, right? So if you do the calculation here, the value comes out to be 0.4997. Similarly, I can find out what is the f of x2 here. F of x2, instead of x, I'll be substituting x2 in the objective function. So my x2 will be 0.5005 into 1.5 minus 0.5005 is equal to. If you do this calculation, the value comes out to be 0.500, right? Now let's represent these values accordingly. So here it is now it is 0.4997. So let's I'll be drawing a line. Let's say that this is representing 0.4997, and the other value of x2 is bigger than this 0.4997. So accordingly what will happen is that this line will be bigger. So if this line is 0.4997, the other line that I'm drawing will certainly be on the larger scale. Now see, what we have to do is we have to find out the maximum numbers. Now according to this first iteration that we have made, so we will be calling it as first iteration, right? According to the first iteration that we have made, what we have got is that from 0 to x1, slowly the values are going to increase, and at x1 it is 0.4997. But at x2, you're getting a value as a 0.5002. That means that now particularly in this section, that is from 0 to x1, the values are on the lower side, but we have to maximize. The objective function is to maximize. So what we can eliminate, we can eliminate the region from 0 to x1. So this particular region I can directly eliminate, because what is happening, this particular region is not going to give me the maximum value, right? The maximum value is somewhere in the region of x2, where the particularly x2 is there, where the value is coming out to be on the larger side. So why I'm not going to consider any values between 0 to x1, and for that the logic I have is f of x1, f of x1 is what f of x1 is less than f of x2. For therefore, for maximization, eliminate region left of x1. If it would have been a minimization problem, we would have eliminated the region right of x2. So this region, this particular region we would have eliminated if it would have been a maximization problem, because we were interested in the minimum value, right? If it is a minimization problem, ये वाला जो region है यहाँ का, ये वाला region right of x2 मैंने eliminate किया होता, because हम लोग minimum value में interested है. But अभी क्या हो रहा है, अभी मेरा जो value है वो मेरा objective function maximization का है. So I'll have to consider that particular region which is going to yield me the maximum value, and this particular region, that is from 0 to x1, do not have that particular chance. So we are going to eliminate the new no, we are going to eliminate the region which is left of x1, and hence we will be getting a new interval, right? So when we eliminate, no, we will be getting a new interval. I guess this is not visible. New interval. The new interval that we are going to get is what? The new interval is, from 0.4995 to 1. So this is our new interval, because we have eliminated the region left of x1, right? But x1 is still there in our consideration. So x1 से लेके जो 1 तक का जो रीजन है वो अभी हम लोग क्या करने वाले, कंसिडर करने वाले. तो द न्यू इंटरवल, द प्रीवियस हम लोगों का इंटरवल क्या था, 0 to 1 था. तो अभी उसमें से हम लोगों ने ये डिसाइड किया है कि 0 से लेके 0.4995 के बीच में there is no chance of getting a maximum value. So we are going to eliminate that region. Now in second iteration, the new interval that we have got is 0.4995 to 1. So let's focus on this particular iteration now and move ahead. So I'll be writing here again. New interval is 0.4995 to 1. It is our new interval, right? So here, instead of L0, we'll be getting the length of the interval, that is L1. And L1 will be what? It will be 1 minus 0.4995. Previously, it was 1 minus 0. That came out to be 1. And here it is now 1 minus 0.4995. If you do the calculation, it comes out to be 0.5005. Right? Now what we have to find out? We have to find out the values of x3 and we have to find out the value of x4. The formula remains same. Instead of L0, we are writing L1 by 2 minus delta by 2. And here it will be L1 by 2 plus delta by 2. Right? So here, let's now draw our new region. This is 1. This is 0.4995. This complete region is our L1. I'm hoping you are getting, right? So the value of x3 here can be written as, x3 particularly will be what? X3 will be L1 by 2. So that is 0.5000 by 2 minus, what is our delta? 0.001 divided by 2, right? And the value, if you do the calculation, comes out to be 0.7492, right? Similarly, if we do L1 by 2 plus delta by 2, that is 0.5005 divided by 2 plus 0.001 divided by 2, the value that you are going to get is 0.7502. Right? Now how you are going to get this particular value? Okay, so if you do this calculation, there will be some different value that you are going to get. Plus इसमें हम लोगों को 0.4995 करना पड़ेगा. Okay, I'll be taking a new page and I'll be making you understand, because this is somewhat confusing, and let's clear your confusion as well, right? So I'll be starting from first. New interval, just give me a second. The new interval that we have is what? It is 0.4995 comma 1, right? So the L1 we are going to get is 1 minus 0.4995 is equal to 0.5005, right? Now our x3 and x4 we have to decide. X3 is our 0.5005 divided by 2 minus L1 delta कितना 0.001 divided by 2. Here it will be 0.5005 divided by 2 plus 0.001 divided by 2. So now when we are going to take you are going to get some values which are not realistic. while making them, if I have to make them realistic, I will have to add 0.4995, which is our initial interval. Here it is 0.4995. I'll be making you understand why we are going to add this value, right? So can anyone tell me the value of now in the calculator? Can you solve this only 0.5005 divided by 2 minus 0.001 divided by 2 and tell me the answer in the chat box. Yeah, anyone in the chat box? 0.5005 divided by 2 minus it is 0.2498, right? So no, yeah, to 0.2497, 0.2498. Now if you see this particular diagram, is there a value? No, we are dealing with a value which is between 0.4995 and 1. so is 0.2498 between 0.495 and 1? No, it is not between that particular value. So what we'll have to do, irrespective of x1 or x2, you're going to add 0.4995 so that it will come in the range, right? So when you add 0.4995 to your 0.2498, what you told me, the value will be coming out to be 0.7492. You can check with the value 0.7492, and here it will be coming out to be 0.7502. Is it coming the same? I'm hoping that the value will come same, right? So now what we are going to do is, now we know f of x, no, what we know is x3 and x4. So what we are going to find out is f of x3, which is equal to what? 0.7492 into 1.5 minus 0.7492. Similarly, here f of your x4 will be 0.749, sorry, 0.7502 into 1.5 minus 0.7502, right? If you do this calculation, you'll be getting the value of 0.5625, and here you'll be getting the value as 0.4625. Sorry, 5625. Right? So here somewhere it was particularly your x3 and x4. Now what is happening is that 0.5625, the same value that you are getting in for both the variables x3 and x4, that suggests that you have reached the maximum value. So here what is happening here, when two functional values at a particular interval are matching, so that suggests that you have reached the you have to stop the iteration, hence stop iteration, hence stop this iteration, right? But no, now we cannot say that there are 2 points, x3b point or x4b point. No, we cannot tell that. What we have to give is, we have to give a single point, that is f x star, which is nothing but the optimal point. And if this happens when there are the functional values are coming to be equal, what we do is that we take average of these values of x3 and x4. So what is x star here now? X star is equal to x3 plus x4 divided by 2. So what is your x3? X3 is 0.7492 plus 0.7502 is your x4, and divided by 2 will be your optimal point. And if you do the calculation, it comes out to be 0.7497. Now you also have to give f of x star. If you do the f of x star, it will be obviously 0.5625. So this is your final answer for the numerical that we are seeing with the dichotomous search method, right? So this is the final answer. So the maximum, no, but the point which is going to give the maximum value for the function x into bracket 1.5 minus x in the interval 0 to 1 is the point 0.7497, and the functional value across this is 0.5625. Right? So the functional value, now in 0 to 1 you put any value, you are not going to get the value greater than 0.5625, right? So now we were to think of particularly what was the significance of 10% of the accuracy. Now the value of the now the value of the percentage of the accuracy in the numerical is going to help us to understand till how many variables you will have to calculate, or how many iterations. Indirectly it will be telling yes, telling you how many iterations that you need to do, right? But there is a formula for doing so, and that is just now here we haven't considered the 10% accuracy, then also we have got the answer. But if the 10% accuracy thing is to be considered, the 10% accuracy thing literally means that it is going to give you the number of iterations. So it is a very small derivation. I'll be explaining it in next 2-3 minutes, and then particularly you can think of accuracy. So accuracy given was, we have actually finished with the problem. But when this accuracy values, how this accuracy value helps us, that we are going to see. The accuracy value is, they have told in us in the numerical that it is 10%. So now we have a formula 1 by 2 ln by L0 is proportional to the alpha. And now here alpha is particularly the accuracy divided by 100. So it is 10, alpha is equal to 10 by 100 in this particular case. It is equal to 1 by 10, right? Again, therefore we can write 1 by 2 ln by L0. It is directly proportional, so I can write is equal to 1 by 10. Therefore ln by L0, if I have to find out, the value comes out to be 1 by 5. Now there is another formula where ln is equal to L0 2 raised to n by 2 plus delta 1 minus 1 by 2 raised to n by 2, right? So dividing by L0 to the above equation, so you'll be getting ln by L0 is equal to 1 by 2 n by 2 plus delta by L0 1 minus 1 2 n by 2, right? So substituting the value 1 by 5 is equal to 1 upon 2 n by 2 plus delta by L0. So it is 1 minus 1 2 n by 2. In our case, they have given us the value of L0. So the interval was 0, 1. So the value of L0 comes out to be 1 minus 0, that is 1. And we can assume delta as a 0.001 if it is not given in the numerical, right? So if we solve ahead this particular, by putting the value, we will be getting that 1 by 5 is equal to 1 upon 2 n by 2 plus 0.001 by L0 is our 1. So 1 minus 1 upon 2 n by 2. We're doing the reductions and all that particular thing. So you'll be getting it as 0.2 is equal to 1 upon 2 n by 2 plus 0.001 minus 0.001 divided by 2 n by 2. So 0.001 can come here. So 0.2 minus 0.001 is equal to 1 minus 0.001 divided by 2 n by 2. So it is 0.11199 is equal to 0.999 upon 2 n by 2. Therefore we can write 2 n by 2 is equal to 0.999 upon 0.199, right? So I think that I'm up till here I'm correct. So 2n by 2 here, particularly we have finished with this page. We can write, we stopped at 2n by 2 is equal to 0.999 divided by 0.199, right? So therefore 2n by 2 is equal to 5.02. And if I have to find out the value of n, I will have to take the log, right? So n by 2 log of 2 is equal to log of 5.02. If you solve it ahead, you'll be getting 0.30n divided by 2 is equal to zero point 0.7. Therefore 0.15n is equal to zero point 0.7, and therefore the value of n comes out to be 4.67, which is approximately equal to 5. Now we know there are particularly we consider the pair of variables, so x1, x2, x3, x4, x5, x6. So according to this particular value 5, it suggests that till x6 you will be getting the optimal value. So in this our numerical, it happened that at x4 only we got that particular value. But according to this 10% accuracy, they are saying that till your fifth, till at x6, you will be getting the optimal value. So this is how this 10% accuracy, particularly plays a role. So when there is any accuracy that has been given into your numerical, so the derivation that I have done, so last 2 pages what we have thought of are to be written prior to solving the numerical. So derivation, and then you'll be solving the numerical. So you'll be putting the values of delta. If it is not given, you'll be putting at 0.001. For L0 in your case, if it is, the interval will be always given. So you'll have the value of L0 will also be changing, and the value of alpha will be changing because it is, it is the accuracy. So these values are changing. Otherwise, this is very simple.